Hi, greetings everyone. Welcome to Module 1A, Intro to Building Services Part 1. My name is Architect Technologies Azrul Ismail, and I will be the lecturer for this module. Let's start. Okay, what is building services definition? Let's imagine a human body without a soul. You have a complete and perfect figure, beautiful curves, strong bone structure, and athletic muscle. But what if there is no heart, lungs, kidney, vein, and nerve system? These are the organs, right? Now, let's compare a building with human body. Similarly, a beautifully designed building cannot function without its organ, which is all the services installations like air condition, lighting, electrical supply, security, fire safety, water pipes, and sewerage system. In order to make the building livable and function, building services is very vital and important. Building must be designed with features or function to provide 1. Better lighting and visuals. 2. Comfortable space temperature and environment. 3. Convenient power supply for our equipment and appliances. 4. Ease of movement from floor to floor. Next, high quality sanitation and hygienic. And last but not least, safe from hazard and risk of fire. Building services are the mechanical, electrical, and plumbing system in a building. Each system is designed to serve a specific purpose and integrated for the use of building users like us. For example, in a toilet, you need cold water supply, sanitary, and sewerage system. For electric, we need power supply system. For lighting and switches, we need electrical fitting system. Ventilation, we're going to need fan or air conditioning system. Transportation, we need lift and elevators. And last but not least, for the garbage, we need refuse system. How about the design? Well, building services is designed and engineered by mechanical and electrical engineers or M&E engineers and civil and structural engineers or CNS engineers. It is carefully calculated and to comply to a specific local building code requirements. The design will be based on the intended building use. For example, housing, it would be a basic design. Cinema, airport, factory is going to be a little bit more complex building services design. The design consists of not only on the equipments, but also on the installations. For example, like the installation of electric substations, switchboard, wiring system, and light fittings. All these building services systems need maintenance and repair after time. If you can see on the bottom of the slide, this is one example of electrical plant. This is how the M&E engineers design the lighting fittings, the wiring system, as well as the fan. Okay, let's have a look. What are the most common building systems? There are 8 most common building systems in Malaysia. And these 8 systems will be the content of our module. Number 1 is electrical supply system. Number 2 is building lighting system. Number 3 is air conditioning system. Number 4, water supply system. 5. Sanitary and sewerage system. 6. Telephone and communication system or internet LAN system. Number 7. Fire safety system. And last but not least, building transportation system. Let's start with electrical supply system. But before that, we need to understand how we get the power supply from the main electric system. Well, conceptually, electrical supply chain started from a power station that generate electricity from natural resources, for example, like coal, hydroelectric, steam, or even nuclear power. Then it is transmitted throughout the country via national power grid line with few transmission substations. Later, it's been distributed via distribution substation and leveled down the voltage through a local transformer before supplied into buildings like houses and schools. In a bigger buildings, transformer and switch rooms, which is TMB substation, being built to house this equipment safely. Let's have a look at this sample building. This is 6-story building, and this is how the electrical supply system been designed. First and foremost, we need a substation. A substation normally located at the ground floor, but you have to make sure that it's free from any flood or submerged underwater. Inside the substation, there are transformer and also main switchboard, or in short we call it MSB. So from this substation, there will be a trunking of cables, wiring, that going up to each and every floor of the building through what we call electrical riser. So each and every electrical riser, there will be what we call distribution board, where it houses all the switches for electrical distributions. So from this distribution board, we can see wiring system that can be channeled down to all of our power socket and power points. Next, let's have a look on the building lighting system. Basically, building lighting can be categorized into two classifications. Number one is interior, and the second one is exterior building lighting. Building lighting system is designed either by interior designers, architects, and electrical engineers through selection of appropriate light fittings and points. Main objective, number one, is to give proper illumination for the building user in specific tasks. For example, like reading in library, praying in mosque, exhibition in gallery, surgery in hospital, and manufacturing in factory. Lighting also give artistic impression in terms of aesthetic on the building design. Here you can see two examples of lighting application, which is on the top part is indoor lighting to brighten up the corridors in a hospital, and the second one is outdoor lighting to brighten up the walkway or pathway at the landscape area. Right, let's move to the air condition system. In hot climate area like Malaysia, to achieve thermal comfort level in buildings with no natural ventilation, air conditioning system is installed. Designed by electrical engineer, a correct system and specification, for example like how much horsepower or BTU to spec, is important to make sure the air conditioner run efficiently and well performed. Two main categories of aircon system for buildings. One, centralized system. This is a built-in system for bigger buildings like shopping malls, university, airports, and etc. The second category is split unit system, an individual system for smaller space or building like houses, classroom, motels, and etc. This is an example of centralized aircon system, which is using chilled water system. In a huge building like this, we're going to need a water cool chiller that normally located at the basement. With the help of a pump, it will pump the water throughout the system line. For each and every floor, we're going to have AHU or air handling units. This is to blow the cold air and distribute it equally inside the building. And then on the top of the building, we're going to have a cooling tower. So this is to radiate the hot air through the hot water and cool the whole system. To circulate the water throughout the system, we need few pumps. There will be 2 pumps on the cooling tower and another one at the condenser. This is an example of split unit aircon system, more simple and more straightforward. On the left, you can see there are 2 units. Number 1 is outdoor units, or we can call it condenser. It's located outside the building. The function is to blow out the hot air and gain cool air in this aircon system. And the indoor unit, or we call it evaporator, is to blow out the cold air into the buildings or into the rooms. As you can see on the right photo, this is one type of the indoor unit, which is called cassette unit. And on the right bottom, showing a split unit with one condenser unit and multiple indoor units. This is what we call the variable systems. Thank you. I think that will be all for this module, and we shall continue to module 1B for part 2. Thank you for listening.